delta U related to the temperature, and it is related to the specific heat at constant volume or specific heat. Okay, what you are getting, du is given by n cv dt. That relation already I explained in case of thermal properties of matter. Thermal properties of matter I explained in detail. If you don't know that, please go back to that topic and try to understand. If at all you got any doubts, please contact me or mail me, whatever. Okay, no problem. Then du is equal to ncv dt. What about dw? dw is p into dv. P into dv, because the how to calculate the work done in case of thermodynamics, it is nothing but the first topic in thermodynamics, right? There are two important topics in thermodynamics, three important topics, main topics. One is first law of thermodynamics. In that, how we will understand how to calculate work done. Second one, types of thermodynamical process. In that case, we will get the relation between Cp and Cv. Isothermal work done, adiabatic work done. Last one is nothing but heat engine, or second law of thermodynamics, which relates the heat engine and heat pump. So there are three main topics in case of thermodynamics. Okay, I think it is clear. Now dw is equal to p into dv. Okay, now just substitute here. 0 is equal to n cv dt. It is du plus dw is p dv. Okay, call the, what is that? Again what is again what we should take in this case? Cv dt over. What is Cv? Again we got relation. Cv is nothing but R divided by, Cv is nothing but R divided by gamma minus 1. Gamma minus 1. Okay, now substitute all the things here. Again you are getting 0 is equal to n. What is Cv? Cv is nothing but, already we know that Cv, just to substitute Cv here, you are getting R divided by gamma minus 1 dt plus pdv. dt plus pdv. Okay, this is what we are getting. Now what we should see? Substitute. And if you, this is one equation you are getting, right? Just write this equation is either A or 1, whatever you know. Okay, write it is A. Okay, first equation. Now let us go for an ideal gas next, because our duty to get the relation between P and V. Let us go for an ideal gas equation. PV is equal to nRT as a next step. I think children, all those things you realized and understood. You can go back and see again and again this video for your further clarification. Okay, so okay, let me move towards the next topic. Next topic, next step. What is that next step? Actually, we know that in case of the next step, what we should know here, see here, for an ideal gas, ideal gas, PV is equal to nRT. PV is equal to nRT. Okay, PV is equal to nRT. Then from if you go for differentiation, you know that differentiation with respect to time, PV is equal to nRT is given by already we differentiated that equation many more. It is nothing but you should find out, it is d by dt of PV, d by dt of PV is equal to n into P by d by dt of nRT. I will not going to solve all the steps here. I will write a direct equation, because we solved this equation so many times we differentiated, right? So you are getting, it is PdV plus VdP is equal to nR dt is equal to nR dt. Okay, call this equation B. In the previous equation, what we studied, children, in the previous equation already we discussed here. If you see in this case, we got 0 is equal to nR gamma minus 1 dt plus pdv. Okay, what we got. Now our duty to from equations A and B, from equations A and B. I think children you are following. From equations A and B, what you are getting actually in this case, if you write 0 is equal to already we got PdV plus VdP is equal to nRdt. See here nRdt in denominator, nRdt in denominator, right? So nRdt is equal to PdV plus VdP divided by gamma minus 1. Gamma minus 1, you got it, no? Gamma minus 1 plus PdV. Plus PdV. On rearranging what happens children, you can take gamma minus 1 is LCM. Gamma minus 1 is LCM. Gamma minus 1 come towards the left hand side. 0 into something becomes 0. So you know that you no need to say again and again. So you can immediately write here 0 is equal to PdV plus VdP plus PdV into gamma minus 1 as when we converting LCM and simplification. Okay, gamma minus 1 comes here and it becomes 0. So here gamma minus 1 multiplies here. That you know that how to simplify. Okay, I will not going to say that again. After again if you simplify, after again, or if you want me to write all the things, I will write, no problem, is equal to PdV plus VdP plus PdV into gamma minus 1 whole divided by gamma minus 1. Gamma minus 1 comes here and it becomes 0. Ultimate equation you are getting gamma minus 1 like that. Okay. Now let us resolve that again. PdV plus VdP plus PdV into gamma minus PdV. So according to our mathematical relations, mathematical simplification, it becomes like that. So 0 is equal to VdP plus gamma PdV. Okay. Now again if you rearrange what you are getting children actually, VdP, I think you are following, VdP is equal to minus gamma PdV. Minus gamma PdV. Okay. Now again what you should get? Again what you should get in this case? Okay. You are getting that relation. Integral of dP by P is equal to on rearranging, before that we will go here, find out dP by P is equal to minus gamma dV by V. Okay, go for the integration children, because dP by P is equal to minus gamma dV by V. Okay, this is the equation what we got, and we did not approach our ultimate equation relation between P and V. Okay, let us proceed. So on integrating left hand side, that is dP by P, between the limits P initial and P final, because pressure changes from P1 to P2, right? P1 to Pi is P, Pf is P plus dP, is equal to negative gamma integral of dV by V, here Vi to Vf. Okay. Now again you know that all the children, what is integral of dP by P? Integral of dP by P is nothing but ln P. Okay. So if you integrate that, on integrating, you know that integral of dx by x is ln x. Okay. So what you should write here, it is ln P. Between the limits Pi and Pf is equal to minus gamma ln V, Vi to Vf. After that children, your duty to apply the limits, right? Upper limit minus lower limit. First what I will do, a pressure ln Pf minus ln Pi is equal to minus gamma ln Vf minus ln Vi. Again you know that it is ln A ln B, correct? Ln A ln B is nothing but ln A by B, logarithm rules. Okay, ln A by B. So you can write here is nothing but, in this case what you can write, it is ln ln Pf minus Pi is equal to minus gamma ln Vf by Vi. On removing ln, you know that it is gamma ln P. What is that? A ln B means A ln B. On removing ln, A to the power B, B to the power A, B to the power A, correct? Power rule you should use. So you are getting ln Pf by Pi. On removing ln, you are getting only Pf by Pi is equal to Vf by Vi to the power gamma, or you can write it is Pf by Pi is equal to, on rearranging, you are getting Vf to the power gamma divided by Vi to the power gamma. So if you relate here children, now you can get Pf to the power gamma is equal to Pi Vi to the power gamma. This is the adiabatic relation between P and V, or in general you can write it is in general Pv to the power gamma is equal to K is constant. Pv to the power gamma is equal to K is constant. Okay. Now if you plot P versus V graph, okay, P versus V graph, you are getting the plot like that. If you take pressure along x-axis and volume along y-axis, then Pv to the power gamma is equal to like that. This is the variation. Okay, that is the experimental part it goes. This is theoretical relation. You got it, no? So what you can take here, Pv to the power gamma is equal constant, or P is equal to K divided by V to the power gamma, or you can write P is equal to K into V to the power minus gamma, also relation between pressure and V in case of adiabatic process. You got it, no? Children, it is almost end of the class. Okay, already we derived the relation between pressure and volume, relation between volume and temperature. We will relation between pressure and temperature, relation between P and density, and various more important points regarding adiabatic process we will discuss in the next video. Okay, thanks everyone.